Now let's look at examples 1.37, which shows us how to use the log rules or identities or something. 1.37, example 1.37, where we look at this problem where you have ln of 2x minus 3 ln x squared equals 0. And to solve this problem, then you follow all the good old rules of what is that called? Properties of logarithms. Okay. You look at these rules and you see how you can apply to them, and once you apply to them and see if something good comes out of it. That's how you solve these things. So yeah, so let's do that. First, this is ln 2 plus ln x, yeah, minus the exponent goes to the front, that is 6 ln x equals to 0. All right, so if you apply some of the rules, and so you get ln 2 minus 5 ln x equal to 0. And so then you get plus 1 minus 6 is 5. And then you do the algebra now. Again, 5 ln x equal to ln 2. Okay, let's divide by 5. So then natural log of x is ln log of 2 divided by 5. All right, which means by definition, you put the e here. Okay, put a e on both sides, right? Put a e on both sides, which means the e and ln inverse functions cancels out. So you have x equals to e to the power all the stuff. Natural log 2 over 5. Right. Now your book uses a different way of doing this. And that's fine too. This is probably the most normal way of doing it, but there's a specific reason, being that this is a simple example, so you can apply different rules. So we'll try that trick too. So here's the alternative method, okay, to explain what the book did, and it's slightly interesting. So what happens is your book does the opposite somewhat. So we're starting from here again, and you start with natural log of 2x, right? And then you minus, instead of taking it out, which is what you normally do in simplify, because there's a 0 here, things are easier than it looks. So then we'll actually put it back. So this thing go up, multiplies, it becomes ln to the power 6. And then what? And then you this equal to 0, and then you use the subtraction equals to and the subtraction division principle. So you combine these things, okay, subtraction becomes division. 2x divided x to the power 6 equal to 0. And then so this thing becomes natural log of 2 over x to the power 6. And that equals a 0. Sorry, x knock 1 out, it's not 6, 5. Okay, it cancels, 1x get canceled out. So you actually get 5. Now once you have 5, there we go. And then you apply the e on both sides. So to cancel out the natural log, then 2 over x to the 5 equals to e to the power 0, and everything to the power 0 is 1. So then from there, then you get something like x to the power 5. Oops, x to the power 5. You put it up here, equals to 2. Which means that x equal to the 2 to the 5th root, okay, 5. And then you pull out your calculator and come up with something, which the book doesn't even bother with that. So I won't bother either. But this is the same as this if you had to use the calculator and to make it come out. And if you always, and also if you push the right buttons, okay? Because the first time I tried to do this, I didn't push enter one more time, and my calculator gave me a different answer. I was like, what the heck? But if you push the right buttons, it will come out. But we won't do that now because the book didn't. So we don't need the actual number of what it is. This is good enough for the moment. So next, rule chain. Well, next, how do we handle the bases? Chain to base formulas is something, again, that you just have to memorize. And if you haven't done logs for a while, they might become rusty. And when that happens and you need to do logs again, just, take a quick look at it again. So I will write these things down. And of course, for logarithm, you have various requirements for domain or whatever. The numbers have to be positive, and they cannot be 1 for various reasons, because stuff to the power 0 is, stuff to the, to 0 is 1, and then you just don't want to mess with that, okay? So numbers are not 1, because 1 is a waste of time. And then so there is various things that you can remember. So for example, I won't write them all down. We'll just talk about it. A to the power x is b to the power x log b of a. Now that sounds a bit complicated, but it's not. It's just another way of saying what we've been saying this whole time. And then, and of course, if this situation is has to do with e, then let's make this a little brighter. Give me a second here. Okay. Now, I don't know if you can read it, but it's not important. You can look at your own book. So and if it's an e, it has a similar formula. Is again, that looks slightly complicated. It's not something really hard. It's just a repeat of what we said. Here's what matters. Okay, here's the property that's most important. Log a. If you have a log some base of x, that's the same as the log of some other base divided by the log of the new base of the number a. The a is the thing that you had before. This is a very convenient way of changing bases. So then if you have some odd base, and then you can just change it to a common base by this particular formula. In here, the x is a variable, whereas a is just a number. A and b are numbers, where x is your variable. So anytime you have some odd base, which your calculator doesn't give you, okay, the calculator gives you two log values, the base 10 and the base e. But what if you have some other number? Well, this is the formula that you will punch in to translate it to any other number. So, all right. Having said that, we're not going to do the proof because this is just a review. Move along. And then, okay, and we're not going to change bases either. Because here's a quick example, right? What if you have a log base 3 of the number 7? You just do the log of 7 over log of 3. Your book used natural log. You can use any log, the value is the same. And then you'll come up with some kind of number. And we will forget about the Richter scale, because that's more properly taught during the introduction of logs, not review. Next, we'll quickly mention the hyperbolic functions. In case you don't, I never had, if you skipped hyperbolic functions when you were studying before, like pre-calculus, algebra or something, the hyperbolic function is just something that's related to e to the power x. For example, this is called the cosh x. The cosh x is something like e to the power x plus e to the power minus x over 2. And why do you need that? It's just tradition. There's not, and event, and being that it's not used, the hyperbolic function is rarely used. So you'll probably forget it later, and you're lucky to even remember you learned this at some point, or figure out how to pronounce it. You see, even the book. See, the book down here teaches you exactly how to pronounce it. How neat! And the reason they need to do that is because nobody remembers this stuff, right? Anyway, this is the cosine one is called cosh. The sine one is called sinh, and the tangent one, let's not even care. Okay, forget it. Just the hyperbolic function is something that you should look back when it comes in integration or something. Anyways, skip that. Move along. We don't. And then hyperbolic functions have similar qualities as regular sine and cosine. But again, yeah, like when we're going to do that. That's just it's just a cute thing that mathematicians discovered in the past, but it doesn't do anything that I know much. It does something, but not much. So yeah, let's move right along. About evaluating them. Let's not evaluate any hyperbolic functions. It's just e of x, a bunch of ex, e minus x. You punch in the calculator and they all come out. And then the inverse hyperbolic functions are a bunch of formulas here. Again, that's good at some point in integration or something, but we'll deal with that later. Okay, when you need it, you can look it up, and there it is. And move along. Yeah. And with that marks the end of this chapter, which is fantastic, right? And I'm going to look up some algebra problems that's I think is a true review of this class. The the textbook, the Rice University textbook, is it's good that they have the chapter 1 review, but personally I think all this is um, they just go over the algebras and trigonometry and pre-calculus in a quick, rushed way, which I don't think is the best way of of reviewing calculus. I mean, reviewing before calculus. The most important thing to me is let's get the algebra down. So I think I will make another class, another video to cover all the stuff that I think you should know before you do calculus. Yeah.